Now let's solve more problems. So this is number 4. Now simplify. I s raised to power 3 over 2 plus xy minus s raised to power 1 over 2 divided by xy. Now in the question I have this, which I don't think it can be y subscript 3, so I think it should be y raised to power 3. So this question now has fourth, so let's assume it's y raised to power 3 minus s minus y raised to power 1 over 2. Now if I look at the up one, I can say s raised to power half is common. If s raised to power half is common, this will remain x plus s raised to power half y minus 1 divided by sy minus y cubed. So we can say y is common here. It will remain s minus y squared minus s minus y raised to power half. S raised to power half is the same thing as square root. This will be square root of x into s plus square root of s times y minus 1 divided by y into s minus y squared minus x minus y raised to power half. Now there is nothing you can do to this question anymore. You can't simplify further. Nothing can cancel out, so you can stop here. Now that was why I said the question has fault. So now if you watch the video and you know the correct question for this one, please comment it in the comment box so I will solve it. But for this one, this is where we can stop. So now let's move to the second one. I I x raised to power 3 over 4 plus square root of x raised to power 3 over 2. Now this is the same thing as s raised to power 3 over 4 plus s raised to power 3 over 2, everything raised to power half. Now because square roots will change to power half, if you have square root of a, is the same thing as a raised to power half. So I did not bother to explain the first question further because it has fault. So now a raised to power half is root a, is the techniques I want to use here. That means for this one, square root of x raised to power 3 over 2 can be x raised to power 3 over 2 raised to power half. That square root will becomes half, power half. So this will be s raised to power 3 over 4 plus s raised to power 3 over 4, because we say 2 times 2 will give you 4, 3 times 1 will give you 3. Now this is the same thing as s raised to power 4 plus x raised to power 3 over 4 plus x raised to power 3 over 4. How many 3 over x raised to power 3 over 4 like that? That will be 2x raised to power 3 over 4. That is 1x raised to power 3 over 4 plus 1x raised to power 3 over 4. So if you add to the 2, it will be 2x raised to power 3 over 4. We can also change it to root form. So this will be s raised to power 3. Then 2 will be outside. You can also leave your answer this way if you change it to root. This 4 will be inside the root. Then the s cube will be here. And this 2 is the one I write outside. So you can stop there also. So now let's see another question. That is, this is the answer for this one. Is either you stop here or you stop here, anywhere. So now I. So 6 raised to power 2x plus 1 times 9 raised to power s times 4 raised to power 2x. Everything over 18 raised to power x times 2 raised to power x times 12 raised to power 2x. Now you need to split everything to their is either index form or into two prime numbers, or anyhow you can split it into two so that terms can cancel out. Now let's start with 6. I can say 6 is the same thing as 3 times 2. So 6 is 3 times 2, but it is raised to power 2s plus 1. Raised to power 2s plus 1 times 9 is 3 squared, but it is raised to power x times 4 is 2 squared times 2 raised to power s. Everything over, again 6 is 3 times 2, 9 is 3 square, 4 is 2 square. So we just change all those ones to their index form. 18 can be 2 times 9, then raised to power s times 2 raised to power s times 12 can be 4 times 3, then raised to power 2s. Like that. So now the up one can becomes 3 raised to power 2s plus 1 times 2 raised to power 2s plus 1. Why? This 2s plus 1 will affect each power in the bracket. So if you have a b raised to power m outside, that means this m will affect both. This will becomes a raised to power m, b raised to power m. Take notes, it's part of the law of indices. Times, now 3 raised to power 2, this will be 3 raised to power 2x times 2 raised to power 4x, but let me leave this as 4 raised to power 2x because something will cancel out in the denominator here. So leave this one as 4 raised to power 2x. Our aim of splitting this is to cancel out terms. So divided by this also can be 2 raised to power x times 9 raised to power x, because this s can affect the powers of each. So times 2 raised to power x times 4 raised to power 2x times 3 raised to power 2x. So this will becomes the numerator. We can split it again. This will be 3 raised to power 2x times 3 raised to power 1. Now we can split this to get this. I use the dot to represent times. Take note. Times 2 raised to power 2s times 2. So let me use times so you can understand what I'm doing. 3 raised to power 2s times 3 raised to power 1 times 2 raised to power 2s times 2 raised to power 1 times 3 raised to power 2s times 4 raised to power 2s. Everything over. Now this is 2 raised to power s, 2 raised to power s. That 2 will give us 2 raised to power 2x. Remember, in law of indices, if you have the same base, you add the power. S plus s will give us 2x. Take note. Times 3 raised to power 2s, that is 9, because 3 square is 9, times 4 raised to power 2s times 3 raised to power 2x. So now which times will cancel out? You can see that 3 raised to power 2s will cancel out, 3 raised to power 2s will cancel out, 4 raised to power 2s will cancel out, 2 raised to power 2s will cancel out. So it remains 3 times 2, as it remains 3 raised to power 1, 2 raised to power 1, which is 3 times 2. So 3 times 2 is 6. So that means the correct answer to this question is 6. Now let's do the next one. IV. So 9 raised to power 2 over 3 times 27 raised to power minus 1 over 2 divided by 3 raised to power minus 1 over 6 times 3 raised to power minus 2 over 3. Now change everything to its index form. This will becomes 3 raised to power 2, because 3 raised to power 2 is 9, raised to power 2 over 3 times 3 raised to power 3 is 27. Then raised to power minus 1 over 2, as in this one, divided by 3 raised to power minus 1 over 6 plus or minus 2 over 3. Because here the base are equal, then you can add the power. So if I write it straight, this will be 3 raised to power minus 1 over 6, then minus 2 over 3. Now this is the same thing as 3 raised to power 4 over 3 times 3 raised to power minus 3 over 2, because 2 times 2 is 4, divided by, remember any number that stands on its own is divided by 1 over 1. So 3 times this will be minus 3, 1 times 2 will be 2. So the same thing with the other one. So divided by 3 raised to power LCM here is 6. LCM is 6. 6 and 6, 1. 1 times minus 1, that is minus 1. Minus 3 and 6, 2. Then 2 times 2, 4. So this is the same thing as here. Also apply the law of indices. That will be 4 over 3 minus 3 over 2 divided by 3 raised to power minus 5 over 6. So continue here. Now for the up one, we can have 3 raised to power LCM there is 6, as in LCM is 3 and 2. So 3 in 6 is 2. Then 2 times 4, 8. So this is 8 minus, again 2 in 6, 3. 3 times 3, 9. Divided by 3 raised to power minus 5 over 6. So this is 3 raised to power minus 1 over 6, because 8 minus 9 is minus 1 over 6, divided by 3 raised to power minus 5 over 6. In law of indices, a raised to power x divided by a raised to power y is equal to a raised to power s minus y. Or if I say a raised to power s divided by a raised to power y is still a raised to power s minus y. So I will apply the law here. So anytime I have divide, it will change to minus. So this will becomes 3 raised to power minus 1 over 6 minus 5 over 6. So this is the same thing as 3 raised to power minus 1 over 6 plus 5 over 6, because minus times minus is plus. Now this will be 3 raised to power LCM is 6. So that will be minus 1 plus 5. So this is 3 raised to power 4 over 6. So this is 3 raised to power 2 over 3. Like that. Because 2 here 1, 2 here 3. So this can be our answer. Or if you like, can leave your answer in roots form. So this can be 3 then 3 square, because this 3 we write it outside, then 3 square inside, which can be cube root of 9, because 3 square is 9. So if you like, stop here. So if the answer is this, you can still stop here to simplify further. Okay, so now let's do the next one. So that is the answer to IV. Now follow the step so you can write it. Then let's see the V. V, we have 3 brackets 2 raised to power s plus 1 close bracket minus 4 bracket 2 raised to power x minus 1. Everything divided by 2 raised to power s plus 1 minus 2 raised to power x. Now I will need to split the up one. So this is 3 brackets 2 raised to power x times 2 raised to power 1. I can split this to get this. Then minus 4 into brackets 2 raised to the power x times 2 raised to the power minus 1. Can split that one also, divided by, here, 2 raised to the power x times 2 raised to the power 1 minus 2 raised to the power x. Now after you split, sometimes will be common to both sides. If you look at this up one, 2 raised to the power s is here, 2 raised to the power s is also here. So but before that, I can change everything to 1. 3 times 2 will give me 6. So this will be 6 brackets 2 raised to the power x minus 4 brackets 2 raised to the power s times 1 over 2. Why? Because 2 raised to the power minus 1 is 1 over 2. Everything divided by, here, 2 raised to the power s is common to both sides. So if you take 1 out, it remains 2 here, then minus 1. So this is 6 brackets 2 raised to the power x minus 4. Now the 4 can cancel out. 2 here 1, 2 here 2. So 2 brackets 2 raised to the power x divided by 2 raised to the power x brackets 1, because 2 minus 1 is 1. Now the up one, 2 raised to the power x, is common. So take it out. So bracket 6 minus 2 divided by 2 raised to the power s. So 2 raised to the power s will cancel out. So 6 minus 2 is 4. It will remain 6 minus 2. As in, if this one should cancel out, so it will remain 6 minus 2. And 6 minus 2 is 4. So that means the answer to the V is 4. So I'll do the next number in another video. Thank you.